Now, in this lecture, we'll find out the length of line segment X. In the drawing, we have a quarter circle. A or B is a quarter circle. Inside this quarter circle, we have this semicircle. In addition, we know that line segment AO equals to 10 units in its length. And our mission is to find out the length of this line segment AM, that's equal to X, according to what is given in the question. Okay, so first of all, we know that AOB is a quarter circle, and therefore this angle AOB equals to 90 degrees in its size. Angle AOB is a right angle. In addition, side AO must be equal to side OB. They are both the radii of this quarter circle, therefore they are equal to each other. But we know that AO equals to 10 units according to what is given in the question, therefore OB must be also equal to 10 units in its length. So I write it down here that OB equals to 10 units in its length. And OB is not only the radius of this quarter circle, but it is also the diameter of this semicircle. So the diameter OB equals to 10 units in its length, the diameter of this quarter circle. We define the center of this semicircle, this point is P. If the diameter OB of this semicircle equals to 10 units, then the radius OP must be equal to 10 over 2, that is 5. PB is also the radius of this semicircle, therefore it is equal to 5 units in its length. We define the point of tendency of tangent AM with this semicircle as Q. And we join points P and Q together by a straight line. Point P is the center of this semicircle. Point Q is a point on the semicircle itself, therefore PQ is the radius of this semicircle, therefore it is equal to 5 units in its length. And we have here rule number 1. According to rule number 1, the tangent to a circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have tangent AB, that is tangent to this circle at point M. Point M is the point of tendency. And we have the radius OM that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to this rule, rule number 1. I shall implement rule number 1 in our drawing. Why? Because in our drawing we have the radius PQ of this semicircle that is drawn to point Q, that is to say it is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever we have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, it means that this angle equals to 90 degrees, and this again also equals to 90 degrees according to rule number 1. We focus at point A. Here we have rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. We have here the common external point, point P. From the common external point P, we have two tangents to this circle, tangent PA and tangent PB. And according to rule number 2, they are equal to each other. That is to say, PA equals to PB. We can actually implement rule number 2 in our drawing. Why? Because in our drawing, we focus on the common external point, point P. We focus on the common external point, point A. From the common external point, point A, we have two tangents to this semicircle, tangent AO and tangent AQ. And according to rule number 2, they are equal to each other. That is to say, AO equals to AQ. But AO equals to 10, therefore AQ must be also equal to 10 because they are equal to each other. So AQ equals to 10 units in its length. In the next step, we'll extend line segment AM and line segment OB by side line until they touch each other. And we define this touching point of the extended line segment AM and the extended line segment OB is point N. By doing this construction, we created here the big right triangle, triangle AON. We focus on the big right triangle, triangle AON, and we define this angle as angle theta. So in the right triangle AON, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. Likewise, we focus on the right big triangle, the right small triangle, triangle PQN. In the right small triangle, triangle PQN, the right green triangle, triangle PQN, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. So I write it down. According to the same logic, the racing angle here must be equal to 90 degrees minus theta. Okay. In the next step, we will prove that the big right triangle, triangle AON, is similar to the small right triangle, triangle PQN. Okay, so I write it down. We'll prove that the big right triangle, triangle AON is similar to the small green triangle, triangle PQN. The small green right triangle, triangle PQN. So the right triangle AON is similar to the small green triangle, triangle PQN. First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So this is angle AON in the big right triangle AON. And it is equal to this angle, that is angle PQN in the green triangle PQN. Repeat again. Angle AON in the big right triangle AON equals to angle PQN in the green triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles, so we can write down that angle theta equals to itself. So, if we relate to angle theta as it belongs to the big right triangle AON, it will be angle ANO. And it is equal to itself. So if we relate to angle theta as it belongs to the green triangle PQN, it will be angle QNP. Repeat again. This equation means that angle theta equals to itself. We just call to angle theta two different names. Angle theta equals to itself as a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle NAO in the big triangle ANO. And it is equal to this angle, that is actually angle QPN in the green triangle. Repeat again. Angle triangle AON equals to angle QPN in the green triangle. They are both equal to 90 degrees minus theta, and therefore they are equal to each other. So we actually proved that all the three angles in the big right triangle AON are correspondingly equal to all the three angles in the small green triangle PQN. So we actually proved that the big right triangle AON is similar to the small green triangle QPN according to angle similarity rule. So I write it down. Actually proved that the big right triangle AON is similar. This is the sign of similar to the small green triangle PQN according to angle similarity rule. And from the fact that the big triangle AON is similar to the green triangle QPN, we derive that the following relationship exists between their sides. We derive that side AO in the big right triangle AON over side QP in the green triangle QPN again side AO in the big triangle AON over side QP in the small green triangle QPN equals to side AN in the big triangle AON over side PN in the green triangle PQN. Again, it is equal to side AN over side PN, and it is also equal to side ON in the big triangle AON over side QN in the green triangle QPN. So in conclusion, we found out that AO over QP equals to AN over PN equals to ON over QN. AO equals to 10 units in its length over QP. QP equals to 5 units, and it is equals to AN. What is the length of AN? For now it is very easy to see that AN equals to AQ plus QN. That is to say AN equals to AQ, that is 10 plus QN. So in total AN equals to 10 plus QN. AN equals to 10 plus QN over PN. What is the length of PN? From the door it is very easy to see that Pn equals to Pb plus Bn. That is to say Pn equals to Pb, that is 5 plus Bn. So in total Pn equals to 5 plus Bn. Here, Pn equals to 5 plus Bn. And it is equals to On. What is the length of On? The length of On equals to OP plus PB plus Bn. That is to say On in total equals to OP, that is 5, plus PB, that is also 5, plus Bn. So On equals to 5 plus 5, that is 10, plus Bn. So On in total equals to 10 plus Bn. here ON equals to 10 plus BN over QN. QN is the missing side, so we leave it as it is. Here 10 over 5 is 2, so 2 equals to 10 plus QN over 5 plus BN, and it is equals to 10 plus BN over QN. So those two sides are equal to each other, therefore we create equation number 1 from those two sides that are equal to each other. So according to equation number 1, 2 equals to 10 plus Qn over 5 plus Bn. And again, according to equation number 1, we found out that 2 equals to 10 plus Qn over 5 plus Bn. Those two sides are also equal to each other, therefore we create equation number 2 from those two sides that are equal to each other. So according to equation number 2, we will get that two equals to 10 plus Bn over Qn. So we have here two equations. Here we will multiply this equation, equation number 1, by 5 plus Bn. And we get that according to this equation, equation number 1 2 times 5 plus Bn equals to 10 plus Qn. Repeating again. According to equation number 1, we actually found out that two times 5 plus Bn equals to 10 plus Qn. Here we'll open the brackets on this side of this equation, equation number 1, and we get that according to equation number 1, two times 5 is 10, plus 2 times Bn is 2Bn, that is equals to 10 plus Qn. Here we have 10 on both sides of the equation, so 10 will get cancelled and we're left only with Qn that is equals to 2 times Bn. So according to equation number 1, we actually found out that Qn equals to 2 times Bn. Well, according to equation number 2, we have already found out that 2 equals to 10 plus Bn over Qn. So here we multiply this equation, equation number 2 by Qn, and we get that according to this equation, equation number 2, 2 times Qn equals to 10 plus Bn. according to equation number 2, 2 times qn equals to 10 plus bn. But we already found out that according to equation number 1, qn equals to 2 times bn. Therefore, we can substitute qn in this equation number 2, by 2 times bn. We do it now and we get that according to equation number 2, 2 times qn, and qn is 2 times bn. That is equals to 10 plus bn. So if we found out that according to equation number 2, according to equation number 2, 2 times 2bn is 4bn. That is equals to 10 plus bn. Again, according to equation number 2, 4 times bn equals to 10 plus bn. Here we subtract bn from this equation number 2. And you get that according to this equation number 2, 4bn minus bn is 3bn. That is equals to 10. So 3bn equals to 10 according to equation number 2. We'll divide this equation number 2 by 3, and finally we get that according to equation number 2, bn equals to 10 over 3 units. Actually found out that according to equation number 2, bn equals to 10 over 3 units. Can write down in the original drawing that this 9 segment bn equals to 10 over 3 units in its length. According to equation number 1 here, we found out that qn equals to 2 times bn. So qn, according to equation number 1, qn equals to 2 times bn. And bn is 10 over 3, so it is 2 times 10 over 3. 2 times 10 over 3 is 20 over 3. So in conclusion, found out that according to equation number 1, qn equals to 20 over 3 units in its length. Here, this 97 qn equals to 20 over 3 units in its length, so I write it down. 97 qn equals to 20 over 3 units. In the next step, we'll complete this quarter circle to a circle. So we completed this quarter circle to a circle. And we'll extend line segment BO by straight line until it touches the circle. We define the touching point of the extended line segment BO with this circle as point C. Point O is the center of this circle. Point C is the point on the circle itself. Therefore, OC is the radius of this circle. The radius of this circle is the same as the radius of the quarter circle because we just completed the quarter circle to a circle. And the radius of this quarter circle, AO, equals to 10. Therefore, the radius of this circle, CO, must be also equal to 10 units in Israel. In the next step, I will present to you a new rule and we will implement the new rule in our drawing. The new rule is rule number 14. According to rule number 14, in any circle, if we draw two chords A, B and C, D inside the circle, from the current start point, point P, then the following equation will be true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. I repeat again on rule number 14. In the drawing we have this circle and the common start point, point P. From the common start point, point P, we drew two chords inside this circle, chord AB and chord CD. So in this drawing, the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can actually implement rule number 14 in our drawing. Why? Because in our drawing we have the common external point, point N. From the common external point, point N, we have two chords inside this circle, chord MA, chord MA, and the second chord from the same common external point, point N, is chord BC. Okay, so from the common external point, point N, we have two chords, MA and BC inside the circle. So all the requirements of rule number 14 are met, therefore we can implement here rule number 14. According to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. So I write it down. So if we focus on the common external point N, from the common external point N, according to rule number 14, NB times NC equals to NM times NA. I'll repeat again. In our original drawing, if we focus on the common standpoint point N, NB times NC equals to NM times NA. Okay? So here we have to find out the length of this line segment NM. What is the length of this line segment NM? From the drawing itself, it is very easy to see that NM equals to Qn minus Qm. Repeat again. From the drawing itself, it is very easy to see that Nm equals to Qn minus Qm. Okay. So Nm equals to Qn. Qn is 20 over 3 minus Qm. So in conclusion, we actually found out that Nm equals to 20 over 3 minus Qm. Now we will return to rule number 14. According to rule number 14, Nb times Nc equals to Nm times Na. NB equals to 10 over 3 units times NC. NC or Cn, it is the same. Cn in total equals to CO plus OP plus PB plus Bn. Again, Cn in total equals to CO, that is 10, plus OP, that is 5, plus PB, that is also 5. So 10 plus 5 is 20, plus Bn, that is 10 over 3. So in total, Cn equals to 20 plus 10 over 3. Repeat again, NC or Cn equals to 20 plus 10 over 3 units in its length, and it is equals to Nm. Nm, we just right now found out that Nm equals to 20 over 3 minus Qm times Na. What is the length of line segment Na? Na or An, it is the same. An equals to Aq plus Qn. So An equals to Aq, that is 10, plus Qn, that is 20 over 3. So in total, An equals to 10 plus 20 over 3. Repeat again, Na equals to 10 plus 20 over 3 units in its length. So actually found out that according to rule number 14, 10 over 3 times 20 plus 10 over 3. Here we multiply 20 by 3 and then we divide it by 3 in order to have a common factor with 10 over 3. 20 times 3 is 60 and 60 plus 10 is 70. So in total, in the numerator of this expression we have 70 divided by 3 and it is equals to 10 minus 20 over 3 minus qm. Here we will multiply minus qm by 3 and then we divide it by 3 in order to have a common factor with 20 over 3. So in total in the numerator we have 20 minus qm times 3 is minus 3 qm divided by 3 times 10 plus 20 over 3. Here we multiply 10 by 3 and then we divide it by 3 in order to have a common factor with 20 over 3. 10 times 3 is 30, 30 plus 20 is 50. So in total, in the numerator of this expression, we have 50 divided by 3. So here on both sides of this equation, we have in the denominator 3 times 3, that is 9. Therefore, we'll multiply this equation by 9 in order to eliminate the denominator 9. So, after we'll multiply both sides of the equation by 9, in this side of the equation we're left only with 10 times 70. In the other side of the equation, after we multiply it by 9, we're left only with 20 minus 3 qm times 50. Repeat again, we actually found out that ten times 70 equals to 20 minus 3 qm times 50. Here we'll divide this equation by 10 and we get that 10 over 10 is 1, so in this side of the equation we left only with 70. That equals to 20 minus 3 qm times 50, and 50 over 10 is 5. So in conclusion we found out that 70 equals to 20 minus 3 qm times 5. So here we'll open the brackets on this side of this equation and we'll get that 70 equals to 20 times 5 is 100. Minus 3 qm times 5 is minus 15 qm. So in conclusion we found out that $70 equals to 100 minus 15 qm. Here we subtract 70 from this equation. 70 minus 70 is 0. This equals to 100 minus 70 is 30 minus 15 qm. Here we add to this equation 15 qm and we'll get that 15 qm equals to 30. Here we divide this equation by 15 and finally we'll get that qm equals to 30 over 15, that is 2. So we actually found out that line segment QM equals to 2 units in its length. This is line segment QM that is equal to 2 units in its length, so I write it down. QM equals to 2 units. Our mission is to find out the length of this line segment AM that is equal to X. Again, we have to find out the length of AM that is equal to X. From the drawing, it is very easy to see that AM equals to AQ plus QM. AM equals to AQ plus QM. Repeat again. AM equals to AQ plus QM. That is to say, AM equals to AQ, that is 10, plus QM, that is 2. So AM equals to 10 plus 2, that is 12. So in conclusion, we found out that X is equal to AM equals to 12 units in its length. And that is the answer to our question. Repeat again. The length of this line segment AM is equal to X according to what is given in the question. It is equals to 12 units. Okay, so in the next step, I will summarize the lecture. In this lecture, we found out the length of this line segment AM is equal to X according to what is given in the question. So in the domain we have a quarter circle, A or B is a quarter circle. Inside this quarter circle we have this semicircle. In addition, we know that line segment AO equals to 10 units in its length, and our mission is to find out the length of this line segment AM that is equal to X according to what is given in the question. So, first of all, AOB is a quarter circle, and therefore this angle AOB equals to 90 degrees in its size. Side AO equals to side OB. Both those two sides are the radii of this quarter circle, therefore they are equal to each other. But according to what is given in the question, side AO equals to 10 units. Therefore, side OB must be also equal to 10 units in its length. OB equals to 10 units. So, OB is not only the radius of this quarter circle, but it is also the diameter of this semicircle. So OB is the diameter of this semicircle, and it is equal to 10 units in its length. So we defined the center of this semicircle as P. So the radius OP of this semicircle must be equal to 10 over 2, that is 5. The radius PB of this semicircle must be also equal to 10 over 2, that is 5. Okay. We define the point of tendency of tangent AM with this semicircle as Q. Then we join points P and Q together by straight line. Point P is the center of the semicircle, point Q is a point on the semicircle itself, therefore PQ is the radius of this semicircle is equal to 5 units in its length. The radius PQ is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP according to rule number 1. If AM is perpendicular to QP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. Then we focus on the common extent point A. From the common extent point A, we have two tangents to this semicircle, tangent AO and tangent AQ. According to rule number 2, they must be equal to each other. That is to say, AO equals to AQ. But AO is 10, according to what is given in the question, therefore AQ must be also equal to 10 units in itself. AQ equals to 10 units, according to rule number 2. Then we extended side AM and side OB by a straight line until they touch each other. This is their touching point. We define their touching point as point M. By doing this construction, we created here the right big triangle, triangle AON. We focus on the right big triangle, triangle AON. And we define this angle, angle ONA is theta. We continue to focus on the right triangle AON. In the right triangle AON, this angle equals to theta according to our definition. This angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, this equals to 180 degrees. That is the sum of the angles in any triangle. So the missing angle here must be equal to 90 degrees minus theta. Likewise, we focus on the right green triangle, triangle PQN. On the right small triangle, triangle PQN, this angle equals to theta, this angle equals to 90 degrees. Therefore, according to the same logic, the missing angle here must be equal to 90 degrees minus theta. Then we proved that the right big triangle AON is similar to the green triangle, triangle QPN. So why the right big triangle AON is similar to the green triangle, triangle QPN? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, it is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself as a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually proved that all the three angles of the right big triangle AON are correspondingly equal to all the three angles of the green triangle, triangle QPN. Therefore, we actually proved that the right big triangle AON is similar to the green triangle QPN according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derived that the following relationship exists between their sides. That AO in the big triangle AON over QP in the green triangle QPN equals to AN in the big triangle over PN in the green triangle, and it equals to ON in the big triangle over QN in the green triangle. AO is 10, QP is 5, AN, it is equals to AN. What is the length of AN? From the drawing, it is very easy to see that AN equals to AQ plus QN. That is to say, AN equals to AQ, that is 10, plus QN. So in total, AN equals to 10 plus QN. Here, AN here equals to 10 plus QN over PN. What is the length of PN? From the drawing, it is very easy to see that PN equals to PB plus BN. That is to say, PN equals to PB, that is 5 plus BN. So in total, PN equals to 5 plus BN. Here, PN equals to 5 plus BN, and it is equals to ON. What is the length of ON? From the drawing, it is very easy to see that ON equals to OP plus PB plus BN. That is to say, ON in total equals to OP, that is 5, plus PB, that is also 5, plus BN. So ON equals to 5 plus 5 plus BN. That is to say, ON in total equals to 5 plus 5, that is 10 plus BN. So ON equals to 10 plus BN. Here, ON equals to 10 plus BN over QN. QN is the missing sign, so we leave it as it is. So in total, we found out that 10 over 5 is 2, and 2 equals to 10 plus QN over 5 plus BN, and it is also equals to 10 plus BN over QN. Those two sides are equal to each other, so we created the equation number 1. From those two sides, that are equal to each other. According to equation number 1, 2 equals to 10 plus Qn over 5 plus Bn. Those two sides are also equal to each other, so we get the equation number 2 from those two sides that are equal to each other. According to equation number 2, 2 equals to 10 plus Bn over Qn. So we have here those two equations. Here we multiplied this equation number 1 by 5 plus Bn. And we found out that 2 times 5 plus Bn equals to 10 plus Qn. Again, we found out that according to equation number 1, 2 times 5 plus Bn equals to 10 plus Qn. Here we open the brackets on this side of this equation number 1, we found out that 2 times 5 is 10, plus 2 times Bn is 2Bn equals to 10 plus Qn. Here we have 10 on both sides of the equation, so 10 will get cancelled, and we have to leave with Qn, that is equal to 2 times Bn. This is according to equation number 1, while according to equation number 2, 2 equals to 10 plus Bn over Qn. Here we multiplied this equation number 2 by Qn, and found out that 2 times Qn equals to 10 plus Bn. Again, according to equation number 2, 2 times Qn equals to 10 plus Bn. This is according to equation number 2. While according to equation number 1, we have only found out that Qn equals to 2 times Bn. So we can substitute Qn in this equation number 2 by 2 times Bn. We did it, and we found out that according to equation number 2, 2 times Qn, and Qn is 2 times Bn, it is equals to 10 plus Qn. 2 times 2Bn is 4Bn, so 4Bn equals to 10 plus Bn. Here we subtracted Bn from this equation number 2, and found out the 4 times Bn minus Bn is 3 times Bn. So according to equation number 2, 3 times Bn equals to 10. We divided this equation number 2 by 3, and finally found out that Bn equals to 10 over 3 units in its length. This line segment Bn equals to 10 over 3 units in its length. According to equation number 1, we have only found out that Qn equals to 2 times Bn. That is to say, Qn equals to 2 times Bn, and Bn is 10 over 3. So Qn equals to 2 times 10 over 3. 2 times 10 over 3 is 20 over 3. So in conclusion, we found out that Qn equals to 20 over 3 units in its length. Here, this 9 segment Qn equals to 20 over 3 units in its length. Okay, in the next step, we completed this quarter circle to a circle, and we extended side BO by a straight line until it touches the circle. We define the touching point of the extended side BO if this circle is C. So here we have point O is the center of the circle, point C is the point of the circle itself, therefore OC is the radius of the circle that is equal to 10. Why? The radius of the circle is exactly the same of the radius of the quarter circle. Why? Because we just completed the quarter circle to a circle, therefore they have the same radius, that is 10 units. So the radius OC of the circle equals to 10 units in its length. Then I presented to you rule number 14, and we implemented rule number 14 in our drawing. According to rule number 14, in any circle, if we draw two chords AB and CD in the circle, from the common external point P, then the following equation will be true, that PA times PB equals to PC times PD. So we have here a circle, and we have the common external point P. From the common external point P, we draw two chords inside this circle, chord AB and chord CD. So in this drawing, the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can implement rule number 14 in our drawing, why? Because in our drawing, we have the common external point N. From the common external point N, we have two chords inside this circle, chord MA and chord BC. So all the requirements of rule number 14 are met. Therefore, we can implement here rule number 14. According to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. Repeat again on rule number 14. According to rule number 14, if you focus on the current standpoint point N, NB times NC equals to NM times NA. So we found out the length of line segment NM. From the drawing itself, it is very easy to see that NM equals to Qn minus Qm. Again, NM equals to Qn minus Qm. Repeat again. The length of line segment NM is Qn minus Qm. Qn is 20 over 3. So NM equals in total to 20 over 3 minus Qm. Then we return to rule number 14. According to rule number 14, NB times NC equals to NM times NA. NB is 10 over 3. NB is 10 over 3 times NC. What is the length of NC or Cn are the same? It is the same. Cn in total equals to 10 plus 5 plus 5, that is 20, plus 10 over 3. So Cn in total equals to 20 plus 10 over 3. Repeat again. NC or Cn equals to 20 plus 10 over 3, and it is equals to NM. We just right now found out that NM equals to 20 over 3 minus Qm times NA. What is the length of line segment NA? NA or AN is AQ plus QN. That is to say, AN in total equals to AQ, that is 10, plus QN, that is 20 over 3. So in total, AN equals to 10 plus 20 over 3. I repeat again. AN in total equals to 10 plus 20 over 3. So here we have 10 over 3 times 20 plus 10 over 3. Here we multiply 20 by 3 and then we divide it by 3 in order to have a common factor with 10 over 3. So 20 times 3 is 60 and 60 plus 10 is 70. So in total, in the numerator of this expression we have 70 divided by 3. And it is equals to 20 over 3 minus Qm. Here we multiplied minus Qm by 3 and then we divided by 3 in order to have a common factor of 20 over 3. So in the numerator in total we have 20 minus Qm minus 3 is minus 3 Qm. So in total in the numerator of this expression we have 20 minus 3 Qm divided by 3 times 10 plus 20 over 3. Here we multiply 10 by 3 and then we divide it by 3 in order to have a common factor of 20 over 3. 10 times 3 is 30 and 30 plus 20 is 50. So in total in the numerator of this expression we have 50 over 3. So on both sides of the equation, in the denominator of both sides of this equation we have 3 times 3, that is 9. Therefore we multiply this equation by 9 in order to eliminate the denominator, that is 9. And found out after we multiplied the equation by 9, in this side of the equation we have to leave 10 times 70, and the other side of the equation we have to leave 20 minus 3 Qm times 50. Here we divided this equation by 10 and found out that 10 over 10 is 70. That is equals to 20 minus 3 Qm times 50. And 50 over 10 is 5. So in conclusion, we found out that 70 equals to 20 minus 3 Qm times 5. Here we open the brackets on this side of this equation and found out that 70 equals to 5 times 20, that is 100. Minus 3 Qm times 5 is minus 15 Qm. So in conclusion, we found out that 70 equals to 100 minus 15 Qm. Here we subtracted 70 from this equation and found out that 70 minus 70 is 0 and 100 minus 70 is 30. So in conclusion, we found out that 0 equals to 30 minus 15 Qm. Here we added to this equation 15 Qm and finally found out that 15 Qm equals to 30. Here we divided this equation by 15 and finally found out that Qm equals to 2. So the length of this 9797 Qm is 2 units in its length. Our mission is to find out the length of this 97 AM that is equal to x according to what is given us equation. We have to find out the length of this 97 AM that is equal to x. From the domain itself, it is very easy to see that AM in total equals to AQ plus QM. Again, AM equals to AQ plus QM. Repeat again, AM equals to AQ plus QM. AQ is 10 and QM is 2. Again, AQ is 10 and QM is 2. So in total, AM equals to 10 plus 2, that is 12. So actually we found out that x that is equal to AM equals to 12 units in its length. Here, AM that is equal 2x according to what is given us the equation. It is equal to 12 units in slab. Okay, thank you very much.